Greetings and welcome to your geometry recording for the week of May 9. So we are officially in the second week of May, which means we are quickly approaching the end of the school year. So just a friendly reminder that there's about 13 days left in the school year. So make sure you're working towards your goals, whatever that goal is that where you want to finish the school year with your grades. I do have a warm-up question that I would like you to grab your math notebook, open it up, and we have a function. And the function is f of x is equal to x squared plus 2. And remember, a function is just a rule or an equation. And I want you to solve for f of 2 and f of 1/2. So remember, the rules tell you what numbers to plug in to the x in the equation. So go ahead and take a moment to click pause and plug or solve for a and b. All right, so when we see f of 2, that tells us that whenever we see an x in our function, we're going to plug in 2 for x. So the f of 2, our equation rule that we use is x squared. Well, instead of saying x, I'm now going to plug in 2. 2 squared plus 2. So I know that 2 squared is 4, and 4 plus 2 is 6. So the answer would be that f of 2 is equal to 6. With an input of 2, we get an output of 6. We're going to do the same thing for b. That should say b, not a. F of 1/2, I'm going to plug in 1/2 wherever I see an x. So 1/2 squared plus 2. I know 1/2 squared, I'm going to take 1 and square it, and I get 1. And I'm going to take 2 and square it, and I get 4. So 1/4. 1/4 plus 2. In order to add fractions, we have to have the same denominator. So I'm going to multiply 4 on my numerator and our denominator so that I can get 8/4, which is the same thing as 2. And now I can add 1/4 plus 8/4. I can add those and I get 9/4. So that's our answer. So when we put an input of 1/2, we get an output of 9/4. So 9/4 is our answer for that second one. All right, so just a reminder, we are going to be dealing with functions in Unit 9. And again, about 3 weeks left to go the school year. That's about 13 days. So this week, we're going to finish up Unit 9 by taking the test. We're finishing Unit 8. We're going to finish Unit 8 by taking the Unit 8 test. Then we're going to get a preview of what's to come in Unit 9 by taking the pre-test. And then we're going to start on the last unit of the school year, which is Unit 9. We're only going to do Session 1 this week, which is all about transformations. So let's dive right in. So Unit 9, Session 1, the title is Transformations, and we're going to focus on 3 types of transformations. We're going to look at translations. So remember, translations are when you take a point and just move it, or you take a figure and move it horizontally and vertically. So we're keeping the same shape, same size, we're just moving. And then we'll look at reflections. This over here is an example of a reflection. Right here, where in a reflection, you're going to have your points be the same distance away from either the x-axis, if that's your axis of symmetry, or the y-axis. But in reflections, your points will be the same distance away from whatever your axis of reflection is, or your line of reflection. And then the last thing we're going to look at is compressions and stretches, which is what the picture is below. Stretches, that doesn't look like an H. So we're going to look at compressions and stretches. So where we take a figure or a graph. So here we've got a parabola. It's graphed, and if we stretch it out, or if we push it closer together. Compress it. So let's go ahead and talk about those different types of transformations, starting with translations. So I'm going to plot point A right here, and it's got coordinates of -1, 4. So my coordinate is -1, 4. And I'm going to translate that point 4 units up and 2 units left. And we want to find the coordinates of the new point. So one way to do it is actually plot the point like I did here and actually move it. And then just find the coordinates of our new point. So let's go ahead and do that. So we want to go up 1, 2, 3, 4. I'm a little bit above. And then I want to go to the left 1, 2. So my new point is right here. And what are the coordinates of that point? Well, we're at -3. We went to the left -3 from our origin and up 8. So that is our new point. So notice that I have point A here is just a capital A, and then I have capital A with a little tick next to it. That tick lets us know that that is the point that's been translated. So our original point is just plain old A. Our new translated point, I have that little tick next to it to let us know that that point has been translated. Another way is just to start with our original point. So another way we can solve this is just say, okay, point A had the coordinates -1, 4. And then if I move 4 units up, that means I'm going to add to my y coordinate, because when we go up and down, that's always related to our y coordinate. So if I add 4 to my original y coordinate of 4, that's going to give me my new coordinate. And then 2 units left, well, I started at -1, left. Our x coordinate always deals with left or right. Left would mean we're moving -2. Add those together. -1 minus 2 is -3. 4 plus 4 is 8. So this would be the coordinates of our new point, which you can see matches what we have on our coordinate plane. So 2 ways that you can do it. One way is just to say x plus or minus whatever the horizontal movement is going, or y plus or minus whatever vertical movement you're given. And that will give you the new coordinates. I'm going to go on to the next slide, where we look at reflections. So we can reflect across the x or y axis, as I mentioned briefly in our overview from the week. So let's go ahead and plot a point. I'm going to take A, we'll have it right here. We'll call this A. And A has the coordinates of 4 and up 5, so 4, 5 is our coordinates. And first, let's reflect this across the x-axis. So remember, our x-axis is our horizontal axis, so it's this axis here, the x-axis. And when we reflect something across an axis, our x-axis is our line of symmetry. And I mentioned this before, the point needs to be the same distance away from the x-axis on the other side. So here we're 1, 2, 3, 4, 5 units away. So 1, 2, 3, 4, 5 units away, it needs to be on the other side. So our new coordinate reflected is going to be right here. And it will have the coordinates of 4, what are we at? 4, -5. So our original coordinate was 4, and our new one was 5. Or our new one is 4, -5. So when we reflect across the x-axis, we're going to have this pattern where the x-axis always stays the same, but the y coordinate is going to be the opposite. So it's going to be multiplied by a negative, and that will change it to the opposite. Now, what if we take that same point, but we now reflect it across the y-axis? So the y-axis is our vertical axis, and we need to be the same distance away, just like for reflecting across the x-axis. We need to be the same distance away from our y-axis. So here we're 1, 2, 3, 4 away. So we have to be 1, 2, 3, 4 away on the other side. And let's call this, we'll call this our A prime also, because it's just a different reflection. Now we're at negative 4. Negative 4. We're still up 5. So here our original A was, the coordinates were 4, 5. And now are reflected across the y-axis, it's negative 4, 5. So in this case, we saw that just the x coordinates were opposite of one another and the y's stayed the same. And these are the rules you're always going to see happen when we're reflecting across either the x-axis, where only the y coordinates will be the opposite of one another, and then the rule for when we reflect over the y-axis is just that the x coordinates will be opposites of one another and the y coordinates will stay the same. All right, so I'm going to move on to the next slide. Go ahead and click pause if you need more time. All right, so here is something that's probably a little bit more new to you. When we talk about stretching and compressing graphs. So when we talk about stretching, we can either have a horizontal stretch or a vertical stretch. So when we're talking about a horizontal stretch, think of having a graph. So if this is our original graph, and we're going to take each point and pull it away. So here's from the y-axis. So if this is our y-axis, we're going to take each point and pull it away. So we're going to take each point and pull it away for a vertical stretch. We're pulling it away from the y-axis. And that would make our new graph look something like this. So a horizontal stretch, we take each point and pull it away from the y-axis. So make sure you write this down because this is something hard to remember, especially when we're first doing it. So we want to have notes that we can refer back to that helps us get a good visual of what a horizontal stretch looks like. So we talked about rules when we reflect points over an x or y axis. We also have rules that we can use when we're talking about stretches and compressions. So when we're talking about a horizontal stretch, the rule is that the original x and y coordinate, the new coordinate, we're going to take the x and multiply it times whatever the stretch is. Like it'll say it's a horizontal stretch of 4 or horizontal stretch of 5. We're going to take whatever that factor is and multiply it by our x coordinate. That's going to be our new x. But our y will always stay the same. See how if I started with this point and I stretched it away from the x-axis, the only thing that would change in my new point would be the x. I would multiply it by the compression or the stretch factor, but my y would stay the same. And when you have a horizontal stretch, the factor always has to be greater than 1. So write this down. Write this down. It's a good thing to have. But then let's talk about a vertical stretch. So a vertical stretch, now we've got, I'm going to do this in a different color, do it in green. We're pulling it away from the x-axis. So here's our x-axis, here's our coordinate plane, here's our x, here's our y. Let's do a graph. But now we're taking each point and pulling it away from the x-axis. Okay, so again, for vertical stretch, we're pulling away from the x-axis. So each point. So if I choose this point, I'm going to pull it away from the x-axis. So if I choose this point, I'm going to pull it away from the x-axis. If I choose this point, I want to pull it away. So it's going to go this side, so it's going to have now this shape. I'm going to do my new one in blue, where we get a shape like this, where each of our points is being pulled away from the x-axis. So in this case, if we would always say, okay, we've got a vertical stretch by a factor of 2. So to get our new points on our graph, we would take our original points and only our x coordinates would stay the same, but we're going to take that factor, we're going to call that factor A, and multiply it by our y coordinate. So only our y coordinates change, where before our x coordinates change in the horizontal stretch. This will make more sense as you work through it this week. I know this is the first time you're seeing it, so just hang in there. Now let's talk about compressions, where we're going to be taking points and pushing them towards the x and y axis. Where for horizontal stretches, we were taking our points and pulling them away from our x and y axis. Where now we're going to push towards our x and y axis. So compressions we're pushing towards. So let's look at a horizontal compression and see what I mean there. So a horizontal compression, we've got our x and our y coordinate. Let's draw our original graph. So here's our original graph. And to get a horizontal compression, we're going to take each point on our graph and we're going to go towards the y-axis. So we're going to go take our points and push it towards the y-axis. And when we do that, we get just a narrower graph. Just a graph that's a little bit more narrow. And again, to get the new coordinates, in this case, for compression, the factors have to be less than 1 but greater than 0. So we're talking about all of our fractions and decimals. When we have fractions or factors that are fractions or decimals, we know we're dealing with a compression. If we have factors that are greater than 1, we know that we're dealing with stretches, either horizontal or vertical. So that's something to keep in mind, is that when we've got compressions, we're dealing with factors that are less than 1 but greater than 0. If we are told we have a factor of 2, we know that we're dealing with a stretch. If we're told we've got a factor of 1/2, we know we're dealing with a compression. So this is something to keep in mind too, is how do we know a stretch from a compression, and it's dealt with the factor, and you're always going to be told. So again, to find the coordinates, only the x coordinates change when we're talking about horizontal compressions, where we'll take the factor that we're told and multiply it by the x coordinate. The y coordinate will stay the same. The last one we're going to talk about is a vertical compression. So we've got our x and y coordinates. Let's draw in our original graph. And then to have a vertical compression, or a vertical compression, we're going to take each point and we're going to go towards the y-axis. So we're going to push towards the x-axis. So we're going to take each point and go towards the x-axis. So when we do that, we get a shape like that. And in this case, only the y-coordinates will change on our transformed compression, our vertical compression. We multiply it by a factor of the factor times our y-coordinate. So again, the big thing I want you to take from this, this table here is that anytime we're talking about either a vertical or horizontal stretch, our factor has to be greater than 1 for it to be a stretch. So the factor that we're dealing with. If it's greater than 1, we know it's a stretch. If our factor is a fraction or a decimal, and it's between 0 and 1, it's positive, then it would have to be compression. So I'm going to go on to the next slide so you can see a little bit more of what I'm talking about. All right, so here I have the table that we just dealt with so that we can refer back to it. And it says, give the coordinates of a point C. So here's our original point, C. The coordinates are -5, 2. And we want to vertically stretch that point by a factor of 3. What would be the new coordinates after it's been vertically stretched? So here, remember, if it's a stretch, we know that the factor has to be greater than 3. And it is, in fact, we have a factor of 3 that we're vertically stretching it by. So remember, when we're vertically stretching, so here's the vertical column right here. If we're vertically stretching, then we're going to follow this rule right here, where we take our original coordinate and the x coordinate will stay the same, but we will multiply the y coordinate by the factor. And here's our factor, and the factor is 3. So if our original coordinate was -5, 2, that means the x coordinate stays the same. It's going to stay -5, but my y coordinate, I'm going to take my y coordinate and I'm going to multiply it by 3. So remember, my original y coordinate was 2. I'll multiply it by the factor of 3, which is 2 times 3 is 6. So that's my new coordinate. Once we have transformed it, it's going to be -5, 6. Pretty easy, right? Let's try another one. So the second question says, all right, now we've got a point, the original coordinates of point C are 1, 6. And we want to horizontally compress it. We want to horizontally compress it. I'm going to change colors here. We want to vertically or horizontally compress it. So since we're dealing with a compression, remember the factor has to be less than 1. It is, that's correct. It has a factor of 1/2 that we're horizontally compressing it by. So now we want to look at the horizontal compression. So we are following this rule right here, which says we start with our original coordinates, and now the x coordinate changes. We're going to take the x coordinate and multiply it by the factor, and the y coordinate will stay the same. So let's do this out. Our original coordinates were 1, 6. We're going to take 1 and multiply it by the factor of 1/2. 1 times 1/2 is 1/2, and the y coordinate stays the same. So my new coordinate for C is going to be 1/2, 6. So again, something I want you to remember is if we're dealing with stretches, then the factor has to be greater than 1. If we're dealing with a compression, the factor is going to be greater than 0, but less, greater than 0, but less than 1. I did that, that's opposite. That's why it's weird for me. Let me say that again. So the factor has to be less than 1 and greater than 0 for it to be compression. So that's something important to remember. And it can be either a horizontal or vertical stretch, or a horizontal and vertical compression. And we're going to stop there. So let me put up the key phrase assignment. So we talked about how when we talk about horizontal and vertical compressions or stretches, that you're going to be given a factor of how much it compresses or stretches by. So if you're given a factor of 4, is that a compression or a stretch? Will that be a compression or a stretch? And as always, if you need any help with anything as you're working through this week, let me know. I'm here to help.